Hi everyone, welcome to this session. I'm super glad that so many of you turned up. It's really nice to see you all. So I'm Long. I'm a software engineer at Databricks based in the Amsterdam office. I work in data and in Delta. Lately I have been working on the Dynamic Insert Overwrite feature. And in the past, I've also worked on performance optimization projects and also projects on the open source Delta repo such as Delta Connect that came out in Delta 4.0. And today I'm with my co-presenter and my good colleague, Bart Samwel.
Hi, I'm Bart. I work with Long, also based out of Amsterdam, software engineer for Databricks. And I'm also working on Delta. We did a lot of work in the Amsterdam team on various Delta features, including deletion vectors, which you might know about. And yeah, so this is Long's show, so I'm going to give the stage to him, and I'll be back later for some additional content.
Thank you, Bart. So let's talk about the reason why we're here today. So a common ETL scenario is the need to atomically overwrite the latest date partition. So let's say that you are the head of data engineering at a retail company, managing like tons of sales data. And in order to do that, on the left, you have a downstream table called history store sales that is partitioned by date. So you can basically contain the sales record for every day. And on the other side, you have an upstream table called latest updated sales that contains latest sales data coming in. And some of them could be late arriving as well. And so to ensure that your analytics is always up to date, you need to regularly overwrite the latest date partition with fresh data from the latest updated sales table. So let's walk through an example of this overwriting process. So you can see red means that the data is outdated, and green means that the data is a new data coming in. So we already have outdated data for date 9th and 10th because on date 9th, we have 5 spoons instead of 4 spoons. And on date 10th, we have 3 forks and 4 knives instead of 2 forks. So we need to update date 9th and 10th. And so we made the update. And then once again, we refresh the latest updated sales table. And we see that once again, we now have latest data for date 9th. So we found out that on date 10th, we have 2 knives and 2 picks instead of 3 knives, instead of 4 knives. So perhaps someone made a mistake entering the data previously. And we also have 6 scoop on date 11th. So we need to replace all the existing entries for date 10th again, and also to add the entries for date 11th. So hopefully you all get the idea by now. And so based on the example that we just showed, looks like we are presented with the following 3 challenges for our solution. Number 1 is that our solution should only touch the latest change date partition instead of the whole table, because the history store sales table would be quite big. The second thing is that the solution should automatically detect the latest change date partition. And the third thing is that the solution should be simple and intuitive for everyone to use, not just PhD in Databricks. And so based on these 3 challenges, our solution needs to satisfy the following 3 properties. It should be efficient in terms of cost and performance. It should be dynamic, meaning that it can automatically detect the latest change date partition. And also, it should be easy to use. So let's check, let's do like a round of check to see if there's any existing approaches on Databricks that can potentially satisfy the 3 mentioned solution requirements. So approach number 1, some of you might know already, is dynamic partition override that was introduced in Spark a few years ago. So the solution is dynamic, but it's not really easy to use. So this Spark config at the top, spark.sql.source.partition override mode. If you set it to static, then it overrides the whole table. But if you set it to dynamic, then it only touches the latest change date partition. So if you set the wrong config value, then it basically results in a completely different behavior, and it can corrupt your table. And also, like the Spark config that controls this behavior is attached to the Spark session instead of the SQL statement itself. and it can be far away from the actual statement. So this makes it easy to forget about this config, even though it's such an important config. And also, the solution doesn't show the partition keys. So you cannot easily see from the get-go what the solution is actually doing. And another limitation that we will touch upon at a later part of the presentation is that this solution only works for the full set of tables partition key, neither liquid nor normal keys. Second approach is replace where. That some of you might know already. That was introduced in Databricks a couple years ago. It's easy to use. It's efficient. Replace where consists of a delete and insert, and we optimize it by parallelizing the delete and insert. And also, we ensure that the source query is only read once, even though they are delete and insert. But however, the solution is not dynamic. You need to hard code the date to overwrite, so you need to constantly update the graph filter to only overwrite the latest change date partition. So this practically makes it unusable. And also, the predicate cannot reference the source query columns. What I mean by the source query is that the select star from latest updated sales. So this means that you cannot add a subquery in the where filter to automatically fetch the latest change date partition. And last but not least, you can use transaction. It's dynamic, but as you can already see, it's like quite complicated and it's not so easy to use. And it's not so efficient because you can notice that the source data here is read multiple times by the delete and by the insert. So here's the summary of the three approaches with regards to the three requirements. And as you can see, none of them satisfied all the requirements. But is this the end? Can we do better? Can we have a solution that overcomes this restriction? So I'm very, very excited to announce to you replace using. Replace using is simple. It has no knobs. It's dynamic. It's flexible. You can customize the matching logic by specifying any list of columns, not just a list of partition columns. And it's also efficient. Replace using also had a delete and insert like replace where, and we also parallelize the delete and insert. And also we ensure the source query is only read once. But one caveat about replace using is that it's not no safe because it follows the default SQL equality like join using. So what do I mean by not no safe? So this means that if you have a no date in your history store sales table, then new data with a no date won't overwrite the no partition, and instead it would append data to the no partition always. And so let's say that you want to treat no like any other values, then we have a complement solution called replace on. So with replace on, it's quite similar to replace using, but instead of specifying a list of columns, you specify a Boolean matching condition like join on. And as you can see, this matching logic is more flexible than replace using. So here you can use like the spaceship or the SQL no save equality to handle no's basically. The only downside is that this syntax is slightly more complex than replace using. Here's also the connection between replace using and replace on. When you specify a list of columns in replace using, this is equivalent to specifying a list of equality condition for each column, and then you connect this condition by a logical AND in replace on. Here's also the Scala and Python data frame APIs that you can use. And as you can see, it's quite similar to the SQL version. You specify a list of columns for replace using, and you specify the Boolean matching condition for replace on. And so some of you might wonder, why don't we use merge in this case? Merge is very well known by everyone, and it's the workhorse of ETL on Databricks. And so for this part, I would hand it over to our merge expert, Bart Samwel. Take it away, Bart.
I want that. So yeah, this is a question that I got a number of times when we were talking to people about this replace using, replace where, replace on. Why not use merge? Because merge is intended to take in new data from a data source and just replace the existing rows that you have, right? It's supposed to be able to do this. Now, if you actually go and look at what merge does, then it turns out that it can't. And I just want to convince you of this by actually showing you what happens if you try to do this. So here's attempt number 1 that you could do. So let's say that you just merge by date. So we have the same example as in the introduction. So you do merge on and match on the date column, and just a simple upsert criterion. So when matched, then update. When not matched, then you insert the row. Super simple upsert. And now what you can see is that it does match all the rows for the corresponding dates. But what goes wrong is this thing at the bottom. You see the 2 arrows from the right table pointing at one row at the left table. The problem is that merge actually, the way that it works is you actually give an instruction for how to modify each row in your target table. And that instruction has to be unambiguous. And it's based on the row that matches it from your source table. In this case, there's actually 2 rows from your source table matching that row. So doesn't work because you have an ambiguous instruction. You're not going to be able to say update this row with both those rows. So this doesn't work. So let's try the other obvious thing. So let's see if we can do this by taking a unique key and actually using that for the upsert. Well, what happens if we do that? Okay, it's great. So the knife at the bottom, it doesn't have a match because there is no knife in the target table. So yes, it will be inserted. The spoon and the fork, they have matching keys in the target table. So they will be updated. Great. But actually, there's that row on the left. What's going to happen with that? That row is also on date the 10th. It doesn't have a corresponding row in your source table. So who's going to delete that row? We were supposed to replace the entire partition. We have new data for the entire partition of June 10th. But nothing in this merge is going to match that, so nothing is going to delete that row. So this attempt, once again, failed. So this is why merge cannot do it. All of the obvious ways to do it just don't do it. And the reason is fundamentally that merge operates on a per row basis. And we're really thinking of a per partition or per groups of rows basis for this new feature. So let's move on to something else. So as Long alluded to before, the old solution that we had with the configuration, the dynamic partition overwrite, required you to replace data just by your partition keys. But we've been telling people that partitioning, Hive-style partitioning, is a thing of the past, and you should really be using liquid clustering because it's more flexible. You can change it whenever you want. It doesn't have problems with bad file sizes, etc. All sorts of advantages, better concurrency, all sorts of reasons why you want that. But the old solution didn't work. Well, replace using will work with your liquid cluster tables. And to make it better, actually you can specify arbitrary keys. So it doesn't matter which keys you use. You can just replace using date if your partition key is by customer ID or by whatever your table is partitioned or clustered by. It doesn't matter. Your replace using works. And with replace on, you can also do even more advanced matching conditions to figure out which rows need to be deleted before you insert your new data. So with that, I'm sure all of you are wondering, when can we start using this? Actually, this feature is one of the most requested features by our customers. So we've been getting requests from this like every couple of weeks for unfortunately too long, but you won't have to wait much longer because replace using is actually available in public preview at Databricks Runtime 16.3, so it's already available with the one restriction that it actually requires you to just use exactly your table's partitioning keys. So it's essentially like your old config-based dynamic partition overwrite, but with the new syntax. In DBR 17.1, we have replace on syntax, so the more advanced syntax that allows you to do everything. And the full support for replace using will be available in DBR 17.2. So that's in a couple of months. I don't remember the exact date, but it's very soon now. So that brings us to the end of this talk. Thank you for listening. So in summary, we have this replace using, efficient, dynamic, easy to use, works everywhere. Replace on for advanced matching logic and if you have nulls. So please try it out when it's available and give us your feedback. We'd love to hear from you. With that, Long, come back on. So that's it for today. So we invite you to come to the stage and ask questions if you have any.